Good morning, good afternoon. Welcome to today's Tech Tips webinar. I'm Guy, the Product Marketing Manager for the Geomagic portfolio, and today I'm joined by Adam again. He is going to be presenting a workflow around scan-to-scan comparisons in Control X. It's a really useful workflow for comparing a run of production parts to your golden, your perfect part. A couple of housekeeping bits. If you've got any questions as you run through the webinar, drop them in the questions panel on the GoToWebinar control panel, and we will get to them at the end. Without further ado, I'll pass over to you.
All right, thanks, Guy. Anyway, we're going to run through, like I said, doing scan-to-scan comparisons. Super useful for when you don't have CAD of the data, or CAD is just like not applicable to the type of data that you're using. We use this a lot in the casting industry. One of the other big things that has started to be used for too is also in like the seating industry. So like when people doing, everything from automotive seating to like couches and chairs and things like that. A lot of times we want to check things like foam padding and stuff like that in those industries. And like no one really makes great CAD of the foam. So they go in and they find something that works, and then they just scan it. And then from the future parts on, they can scan and compare the same thing, make sure they're on track. We'll also use this some in the like tooling, stamp and die industry, just because they'll have intermediate parts where there isn't CAD of the intermediate sections for all those forming activities and things like that. And I'm trying to think of some other stuff. It's kind of all over the place. So lots of molding and everything else, and then like all different types of casting, even besides metal casting. So we're using it. So even for stuff people doing like concrete forms and stuff like that, it can be very useful just to check end parts, to known good parts, rather than trying to get CAD that's modified for things that shrink or deform on cure and stuff like that as final parts. So I didn't make a ton of slides because nobody likes slides, because slides are boring. So I'm just going to jump like right into CX here and start running through some stuff. And I'm going to go and kill my video just so you don't watch me scratching my face while I'm doing CX. But anyway, a couple things that I like to do is, Control X normally opens in result data, just sitting here like ready to go. And for a lot of these workflows, I really like to start in input data. I don't think input data is something that people kind of use enough when setting up things. So this is kind of the data warehouse where all the things get stored in CX. So even if in Control X, even if I imported a bunch of things into result and deleted them out, they would still be floating in here. So just think of this as like a data warehouse. If I bring in 5 parts and I want to make different results with different parts in them, they're all going to live in here. And this is where I like to do a lot of my prep. So if I bring in CAD models, we'll just bring in my my reference STL just so we have something in here to play with. And then so you'll see where the origin of this part is and things like that. Often with even normal CAD workflows, the CAD origin, that's where it's drawn, may not be what's on your print and things like that. So a lot of times if we want to do ordinate dimensions on prints and stuff coming from the left hand of a part or something like that we want to check and send back to machining and other things like that. The input data is where you're going to do all of that translation of CAD objects and things like that if you want to move stuff and have it just set and change things on the CAD bodies. This is also generally where I like to do like measured data cleanup and stuff like that to prep my parts. So if I have some scan objects coming in and I want to come in and I have multiple scan sets, or I want to do cleanup, I sort of do all that in here. This part I already prepped, so you don't have to watch me doing all the normal stuff that you would do with just normal scan data for making going apart. I might fill a couple holes in and things like that. For this, there was some areas that were a little hard to scan, like in certain pockets and things. We had some little holes, so I just filled them in to make it look nice. Again, those would just be areas that might show either red or just like no data in gray or something like that on a color map when we're checking this part. So I like to just take care of those little odds and ends when I'm in here. So, but other than that, you want to use a scanner that has obviously great scan coverage on your part, that can see the things you need anyway, because we're using this again as a golden part. So, so I bring a lot of that stuff in. As far as prepping the data, we don't have to decimate it or anything like that. You might want to if the file's really big and you just want smaller files going out. So, but taking care of a lot of that stuff in here is really nice in the input data. And then I'm also going to come in here, and while we're in here is what we do instead of coming through. We can come through obviously and start pulling out things that we want to measure between. We can come in and do what we would normally do and like highlight data and grab a plane and extract it and say like we're going to measure between all this stuff. But pulling out all those individual features, even on this, we're only going to really check. This is an upright for a UTV, so it's cast manufacturer that does that, and then they do some initial machining on the part, so you can see some nice flats on here. And those are kind of things we want to check. We need to check like thicknesses and stuff like that on these areas. And pulling this stuff through, pulling out all these individual features, it would just take a while clicking on it. And this is kind of where CX shines for doing the scan-to-scan styles inspections, because what we added in here, in the invention of CX is we added in region grouping, and this is something that some of our DesignX customers for the reverse engineering might be aware of. But the auto segment here is going to come in and identify like saved selections of scan data and classify them like automatically. So, and then we're just going to use kind of default settings here. So I'm just going to come in, and I'm actually going to leave this at around 40 or 50. So depending on where I put this depends on how much it divides up the shape. So I'm going to turn off this merge same primitives because I want individual planes. I don't want, what this will actually do is if I leave this on, if these two planes are at the same height, it might classify them as the same plane, and I would want them as different planes just because I want to measure between here and I want to measure between there as two different objects. So I'm going to uncheck that. Normally very handy though if you have stuff that is coplanar or like coaxial for cylinders. It's nice to leave that on if you want it to all be considered as the same feature. It'll automatically do that. And I'm just going to hit preview here. Always use the preview. It's just faster if you want to adjust things later. So, and I'm just going to hit go on this and let it chunk for a second here to give me the regions. So, and then the reason I want it pretty low is if I turn this up really, really high, any of my larger sections or faces or cylinders, if there's any little burbles in the scan data and stuff, you can see we would just end up with lots of little regions. So I want this big surface to be a single region. I don't want it to be divided up. So, and I can show you, if I really crank this puppy up and hit go here, this mesh doesn't take too long to calculate on. And I have a newer, fancier computer, so we'll let this go, but you'll see that like when I crank all this up, we're just gonna get a ton more regions on all the data. I should have turned it up to 11 all the way. But actually we're still not dividing the faces out because they're really clean. So, but you can see we don't really need this super patchwork of like high density all over the place with every little bit of curvature. So I generally say less is more when it comes to regions. You can always add or clean up or divide things in. I did like that 40, so we're just gonna go back there. So. And then if there's anything we want to change or add in, we have the ability to edit these things. So we're going to give this another second here. And the region colors are essentially, they're just meaningless. They're just randomly assigned. So, and then I just want to look for things being divided up accurately. So this is pretty nice. It's covering the face. Obviously we don't want like little fillets on the edge of faces being encompassed in the region. So we have like a little bit of that there. We might want to like modify, but I just give it a good once over and look to make sure the areas that I want to clean and measure, that I want clean and I'm going to measure on are pretty much combined. Like this face is just a cast face. And this was actually like a hole that I filled on here because there was like a burble on the bottom. So I kind of like chopped that out and cleaned it. So it's a little weird. So we're actually going to modify this one a little bit, but Other than that, it looks pretty good. So I'm just gonna hit check on this, bake them in. And then you'll notice when I mouse over the part now, it has these things classified already. So I don't have to go through and automatically extract like all the planes that I want to measure between. So like at this point, anything that I see that's like a plane or a cylinder, yeah, it says your cones because they are cones. If I came down and I don't know if I found an edge in here or something like that, it's probably going to be classified as a cylinder. So that saves me a ton of time and lots of clicking from having to go in and manually extract like things from scan data that we want to measure. So all the things that even if we manually extracted them all, like we could automatically, refresh the data and, as a reference object, and it would find, what we're bringing in as test objects to go along with it and automatically compute the dimensions. But doing it this way, I think it's just a lot nicer. This is going to be baked onto our reference part. So what I want to do is, do any cleanup I have here, and then this is always going to stay the same in the background. So this is going to be our like CAD part, our golden part that we're comparing to. So what I'm going to do is, I like using the paintbrush when I'm modifying regions. If you Alt and left click for the paintbrush, you can kind of change the size here. But what I'm going to do is, instead of using that as it is, I'm just going to grab this flatter section kind of up top here. And again, I don't want to come too far out to the edges, so let's just like do this and grab this area. I'm just going to hit insert, and you'll see we get a new one here. So we're just going to use that as our plane in that section. And if I'm worried about any data encroachment on some of these other things, I don't remember where I saw that, like on the bottom here, again, maybe we won't use the whole face. We'll just do something like this. And you can see the triangle tessellation on some of these flat panes is a little coarse, but we're going to do something like that. Just get away from edges. That was already pulled back pretty well. This flat is saying it's part of it, but if I think that's a little aggressive on parts coming in, maybe they're not all going to be exactly like that. I already know it. I can come in and just add things, and you'll see it's automatically classifying all that stuff. So really easy to clean up and modify. And again, I just want to make sure these are all individuals, so I'll mouse over them. And then, we're pretty much good to go at this point. So now we can come in and start putting heights and things on here that we want to do. So I'm actually going to do my my other import here. So I'm going to pull in my test object just for fun. And maybe I have that data in inches. I probably do. We'll know if I bring it in the wrong size. Yeah, it's in there. So I'm going to change. What I like to do for some of these objects is blue is like our standard scan data color. So it's kind of off-putting when I have, to me anyway, when I have this in here and it's all blue as my reference object. So I'm going to actually come in to properties here. Is what I usually do is come in and I come down and make this like the shiny cat gray here. So like for the little white dot there, just shows you kind of how shiny some of the objects are. So this would be like a pretty shiny, normal looking CAD object. So we want to do that because that's our reference data and it won't confuse me. And then I'll actually come in to this one if I want to. And purple dark is kind of hard to see. So I'm going to come in and make that blue. And then what I'm going to do is get this ref data and I'm going to add this to the result. I'm not going to add the scan to the result yet from my test object. So I'm just going to bring this in and all the regions will be there already. And then what I'll do is, since I already made all that, I'll hit move to reference. And then now you'll see all the regions are highlighted now that it's like set as reference data. So you can, if you want to, like turn all the colors back on. So if I come into region here, we can like see everything just as we did before, but the default kind of view is just going to be the standard color with the boundary lines like you would have on CAD. So At this point, we can come in and just start adding dimensions like it's CAD. So again, I don't have to pull anything out and do stuff, so we can just figure out what we want to do as kind of our views. I don't know what front is on this, so it's the top view here, which is pretty good. So maybe we'll start here, add a couple things of what's going on that are easily visible in this view, and then maybe make some custom views and stuff. So at this point, though, I can come in and start adding, maybe I should have changed that region. We could always go back and input data and do that, but I'm just going to come back in and like grab these. And then what we'll get a lot of times when I'll click on these things is if I click on the dimension, it's going to say these aren't parallel. And we know this because it's a cast object. They were roughly machined flat just to get somewhere else. But being what this part is, the parallelism isn't necessarily important for these because they're going to have just drilled holes in them and then spherical bearings are going to be pushed in. So the parallelism of the sides doesn't really matter anyway. But CAD, it would be parallel, but on the cast part, it doesn't really matter. So we just hit, OK on that warning that we're getting that they're not totally parallel. What it's going to do is it's going to, by default, when you have things that aren't parallel and things like that, in any metrology software, when you click on the first face, it automatically takes a perpendicular line to whatever the second face is that you're taking on. So it's like center mass to that perpendicular face, straight out to wherever it intersects here. So you just want to think about that with which side you click on first, because that's going to be the basis for the direction of your dimension. And then we can come in and put some tolerance thing on here. Now, the other thing is this is the actual as measured part. So it's actually 27.798 millimeters. That's probably not as designed. So if we want to, based on a print or whatever, we know this should be 28 or something like that. We can come in and like override these and do like a plus or minus 0.2 on them. So maybe this one was a little bit undersized, okay? And we would want to showcase that. So if we think it goes the other way, I mean, maybe it should have been like 27.5. We'll know in a bit here. So let's click on another side. I don't have a print for this, so I'm just going to come in and grab this other side while we're here looking from this top view, do the same thing. So this one's like 31.5 for the thickness. So again, maybe this should be like 31. So, and then the other thing I'd probably want to do on a lot of these cast parts that I'm kind of not showing right now is most likely I would want to come in and do a, usually you're doing like bilateral tolerancing. So normally I'm going to come in and say like we want to do like -0 and then to like positive like 2, something like that. So we're going to say like anything undersized from whatever our design spec is, we might not want, or there may be like a negative small value, positive like big value, because obviously these things need to be beefy enough to hold up. And then usually in automotive, we're going to make sure stuff doesn't get too heavy by leaving just too much material, because obviously we don't want to leave the full amount of material or they wouldn't have us machine these to begin with. So let's put a couple more on here, and then we'll throw some data in here and automatically get to compare. So I think this is, maybe we can get a couple of these from the top view, and then again, we'll just override, this should probably be sure design on 10, and that was probably like 28. And we can come in and just grab our tolerancing to put these things on. So I'm just going to come in and not even actually exit, because you don't have to. I don't know why I keep hitting the check mark when I could just add this stuff in and say, we'll run that. We'll do this. And then this one probably from the top view too, we can do to make it look nice. So we don't want to do that one. I forgot to click off the screen. Again, paying attention where I click is always nice. So and we'll do that guy. And that's probably it for like top view. I usually come into the groups here and I will set up what I want for top view. So we're gonna leave this go here. I'm gonna put these tags where I like them. We can show, I have everything shown on these tags if we want to, but we could always come in and do like a default view. I kind of like seeing the measured value and deviation on the tags, but you can kind of do, you know, whatever works best for you, standard display. You can edit these things all out to be the same if you want to. You know, I could just say that they all should be like default, stuff like that. Change them all at once. And we'll change that back to inherited. But kind of for this, I'm going to leave on the detail just so we can see everything. And then as far as setting views, I always come into like my stock print CAD views if they're set up nice. And these are all going to look a little bit awkward because they're all in different angles. But again, we don't need like 72 pictures in a report. So we're just going to hit OK on that one. And I'll turn this group off, and then we'll think of like, you know, what we want to show. This is probably our, that was front. This should be bottom. So of what would look on that view. So at this point, I'll come in, I'll hit add group, and we'll start doing stuff like on the sides here. So maybe we'll do some, if we want to do some positional stuff. Again, this is kind of boring dimension wise. I just kind of really wanted to show off like how easy it is to do all this stuff. I'm going to set all these as the same tolerance, even though they're probably not in real life. So we'll do that. Put that guy over there. And then, you know, if they want to pull some stuff off of thickness, you know, we might want to show a like cutaway for doing the insides, you know, or we could just do something for front face or make it transparent. Doing stuff interior is always a little bit awkward. So it just depends on what we want to do. So we'll do this. We'll set that up for these guys. We must leave those tags over the part, even though it's not great practice. Here, update on that view of something that we'll put in a report. And then let's come in and look at some of their stuff. So the other thing is what I like to do for showing some of these cutaways is, you know, I like to come into just view clip if we wanted to show some cutaway stuff. And then I'm actually going to say, like, let's look in our Y direction here. Let's maybe look from the bottom and we'll flip this around. And that should be like 0 and 0 and -1 if we want to really square it up. As far as position, you know, I don't know, we can come down to like the origin if we wanted to for those couple pieces. And then one of the things that I like to do when I'm doing this is I like to, and I don't know how much you use view clip, I use it a ton. And I'll like come in and generally for just showing the inside of the CAD, like we don't do a fill. So what I normally do is for the back face, I usually come in and say like user defined, and then like I'll come in and pick a defined back color so that I want to use for that. And I just like making it red because then it's really obvious that that's like the inside of the part. So, and then we can come in and start adding things, you know, like we would do normally. So again, it's just the view clip is just chopping data. So we can use all the stuff here. And we'll just override, you know, that should be like a 40. So that's kind of enough. I'm going to move that to group 3 where it should be. I forgot to change and add a group. So we'll do that. You know, look at the bottom the way it's supposed to be. And then again, I like to go along and set up the groups. I even usually a lot of times will set up some of these views before I put in all the dimensions, even just so it's lined up with I'm just trying to figure out what my plan is, especially if I don't have a print to work on that I have like certain custom views on. So, and then from here, I'm just going to turn all these guys like back on just so we can see what calculates. And then when I input my data, I already have it in here, so I could always just come in and say, like, this is my scan data. I'm going to add that to the result. It always asks me, like, do I want to align? I always said no, and then I'll hit my initial alignment here. This one we can generally run just like a quick initial. And because it's a pretty simple part here, and then come in and I always run a best fit generally afterwards, and we can decide whether we want to fit to the pads. If we select the data, normally you could just best fit to the whole object is probably what they would want to go for this to make sure nothing is like grossly out. So let's do one. We're just going to the entire object, and I didn't throw a color map on here yet, so let's do that too, just so we can check over all the rest of the part. And we will come in and do like the whole part here. And we're not going to do whiskers, we're going to do color map. And then specify some tolerancing here. So you can see this is all pretty close here. So we'll come in and say like, let's show the tolerance color. Maybe we have that set overall, and then we want to like make this like, I don't know. Really just highlight anything that's wrong. Obviously they should be really, really close because they're coming out of the same casting. So there shouldn't be any gross differences anywhere. So I like to kind of overemphasize the color map. And if we just turn off our tags here, we can take a look and see what we find. So, the way, the parts best fit all to itself. We're finding some things like where there was some divot in that casting. And I did fill a bit of hole here. That wasn't actually like a machine surface though. And then everything else looks pretty good. So we can just see some errors around some of the edges and some fill and stuff like that. And then maybe there was like a little divot on that face there where something didn't fill all the way and machining didn't clean it up. So, and then this interface is just high. So we can see that right away, check it. So usually, once you have your color map set up, throw your part in, throw your dimensions in, we're only gonna have to do this once. So, and then, I overrid some of these dimensions. I think I went the right way, but we're showing some things are a little undercut of what we want if we wanted to do like -0 because we only want them minimum thickness. So we're showing a little low on some of that stuff. But so some of the things were a little undercut based on our tolerance of 0 negative. So we highlight and flag those things right away. And we could do a bidirectional color map too, like if we wanted to show up anything that was just grossly low or something like that, we could set that up. But from here on out, this is our program. If we wanted to see some stuff for different from manufacturing, we can set that up. But like from here on out, would come into replace measure data. Again, I would grab my next part, hit run inspection process. I have a default. I guess I save that data in inches, but anyway. So, and now it's going to come in. It'll add data, and then it will automatically align it and compute all my dimensions, and then I just hit print on the report, and I'm done. What just happened? Oh, screen just refreshed. Anyway, so yep. So that's pretty much it. Setting up an inspection process on a golden part for scan data. It's really straightforward, super easy to do. Regions make it really, really nice. So, I mean, it's just the easiest way to do things. You just come in and highlight what you want. You don't have to go through and extract a million features, put your dims on, and then you're kind of good to go. So at this point, if we wanted to say poke around for some stuff for manufacturing or whatever else, or maybe stuff that wasn't going to go to an end customer or as part of the process, we could come in and do some other fun stuff with like changing results. So like if I wanted to do an alignment just to the machine surfaces or something like that, I'm going to hit just duplicate result here. Let me close the GD&Ts for now. And then like maybe we'll come in and do a selective alignment. Or if we have datums that they wanted to put on this part, again we could do a datum alignment or like a 3-2-1 based on that data. But I'm going to come in here and say like maybe let's just align to, maybe we'll skip that one because that's not a machine pad. Okay, we'll come in and grab stuff like this, and like there's plenty of times where people don't use selected data to the selected data function, like when they're trying to diagnose things in manufacturing for features that matter, or maybe the datum structure on the part isn't really conducive to what features matter for machining processes and stuff like that, for fixturing and other things like that. So doing this selected data only alignment can really show off some things in the part. So let's turn our compare back on, just so it'll rebuild when we're out here. So let's just grab all these things that we machined in that matter for the part, and like let's align to like all of them, and then see if like maybe see if the casting is out or something like that, because maybe we kind of shifted all those faces in the background and we didn't really know. So I'll come in now. I'm going to turn these back off, and we'll just hit rebuild. So, and then we can recheck out the color map here, but nothing really changed. So if I push the alignment like that to some other features, even ones that I know that like were under machined based on dimensions and things like that, and I float them all in and they all fit, and then like nothing else changes on the part, I know that I didn't really shift anything in like one particular direction or the other. So there's a lot of investigative tools in here that you can do with scan-to-scan stuff in your processes. So good benefit of using all that, even when you can go to CAD and stuff like that. Checking part to part can tell you things that go in, and checking back to CAD, like doesn't always tell you about consistency and process and things like that. So, but yeah, that's kind of a short and sweet little scan-to-scan inspection. So I don't know if you guys have any questions and things like that are going on here, but.
Thank you, Adam. It was great. Yeah, as Adam said, any questions on anything he's covered?
But there are a bunch of different uses for running through this stuff. So it's just kind of the sky's the limit. We use it a ton in additive too, and I didn't even mention that in the beginning, which was kind of silly. But we use a ton in additive for doing printed parts to each other. So just because a lot of times there's other structures on those parts for support, or there's like added material in spots that we use to stop things from like warp during print or whatever. There may be some other design features on, or even just checking like where the support structures are to where the support structures are. It's very handy to just scan those in and check them all out. And those aren't generally like CAD objects that are baked into design of the part. They're really just part of the slicing software and things like that. So another good little application for doing that stuff. So,
right. If we don't have any questions, then we will give you 20 minutes back. Really appreciate you taking the time, Adam. Thank you, everyone, for joining. And hopefully we will see you in next month's Tech Tips webinar.
All right, guys. Thanks for coming out.
Cheers, everyone.